Let's do one more. Let's do the weird one. Let's get strange. What if I have my lens like this, and I put the focus here, and the focus here, and I put the object inside the focus, really close. Now let's see what's going to happen. Well, you can always draw this one. Light goes to the lens, and then it goes through the focus. All right, and then you can draw this one. Light goes through the center. Right? And maybe you can tell those are not coming together. Those are going apart. Those are diverging. And let's see, how would you draw? You can't draw one back. You can't get to the focus. It's behind you. But what you can do is imagine one that goes like this. It follows that line to the lens, and it will go straight. Right? So what you end up with is these three rays that aren't coming together. So if you put the object inside the focus, you don't get an image on the other side. But you do get one of these virtual images. So if this lens were big enough, then if we draw this one back, so if you have your eyeball over here, you see these rays, and your eye doesn't know about the lens. Your eye thinks they keep going. So this goes like this goes like this goes like this, and you get a virtual image. Right? So you can't put it on a screen. It's not real. It's not a real focusing of light to create an image by isochronous rays, but it is something that you would see if you were to look from this side. And it actually follows the thin lens equation. Everything works out. 1 over SO plus 1 over SI, object distance, image distance equals 1 over F. So 1 over F is a constant. If I make the object distance, and I make this less than F, then let's see, this is going to come out bigger, all right, than that. If this is bigger than that, then this has to be negative, just like we kind of saw when we were doing one refraction for the sphere. If that's negative, then SI has to be negative, because 1 can't be negative. Right? If SI is negative, the image distance is negative. What does that mean? That means it's on this side, right? The image distance is positive on that side of the lens. It's negative on this side. So when the image distance comes out negative, that means you have a virtual image on this side. What about the magnification? Negative, SI over SO. Well, now the distance, SI, the value is negative. Negative, negative makes it positive, and sure enough, it's upright, right? The magnification is positive. And it's magnified pretty big because it comes out back here somewhere, and this distance to SI is bigger than the object distance, which is inside the focus. Right? So it all makes sense. So the thin lens equation and the three easy rays always give you the same answer.